Okay, so what do I mean by real-time computing or real-time communication? I'm sure many of you have heard this phrase. Sorry? Live streaming. So live streaming in some cases would be a consideration for real time. So real time generally means that you're updating things or you're sending communications in a very small amount of time. Usually communication is very quick on the level of milliseconds or microseconds in some cases. Depends on probably who you talk to in computer science, like how short is actually real time. We're probably just interested in this case in like network fast, which is somewhere between 5 and several hundred milliseconds, depending on what your network connection is like. So the only real way that we've talked about doing communication so far in this class is by using HTTP requests, either by loading pages in the browser or by using AJAX. Can we use this mechanism for implementing real-time communications? What do you think? Sorry, I forget your name. What's your
Kit?
Yeah, Kit.
Oh.
Kit.
I don't know how to answer.
Answer that. So
we use Ajax to, we were using Ajax to do the get and push? Is that where?
yeah, to get in post. So
Okay.
we're doing that with the server.
Kind of like Postman, same. You use
Postman
those
is what? That's
functions.
like that's a utility for like.
API access and
Yeah.
gets back JSON files
Yeah. So
from different
we can use
databases.
Ajax to make calls to the server, and we get back a response.
So that would be real time, yeah, to get it.
So depending on how fast the server responds, what is something that we've that you want to do with real-time communication that you potentially can't do with Ajax? So if we're just asking the server for something and they give us something back, yeah, that's kind of real time. But in what situation wouldn't this work necessarily? What if the server is trying to send us some data, but it doesn't have any way for us to tell us that? So say that it gets some incoming event that it knows about that it wants to tell us, but it can't. If it's waiting for us to ask, then that might be some time down the road. So that's not necessarily real time. Does anyone have any ideas about how we could potentially implement something that would enable the server to tell us in real time about an event? Sorry?
Queue mechanisms.
Queue.
Posting a baseline from event, posting it to some queue, and whenever you have message in queue, fetching it from the
So if you have
server
a queue of messages, what is the client having to do then to get those messages? I feel like there's some real Monday going on in here. So Orion, what do you think? So so HTTP is on top of what type of network connection? Talked about this first or second day of class?
It's just TCP.
Yeah, it's a TCP connection, but we're making it so that we connect and we disconnect whenever we're doing HTTP calls. So there's a couple of different ways that we can deal with this. Well, I'm just going to talk about. The first one of these is what's called long polling. Has anybody ever heard of this before? No? Okay. So normally whenever we make an HTTP request, we send a request to the server, it figures out what the answer is supposed to be, and it sends it back to us as soon as possible. So the difference with long polling is that we use the same mechanisms. We use an HTTP request where we make a request to the server, and then it holds on to that. It doesn't respond to us. It like leaves us hanging, basically. And so if we're using XML HTTP requests to do an AJAX call, this is basically just like waiting. The server hasn't responded. Would probably use the that API to set like a really long timeout on the connection, so that it doesn't disconnect because it took too long for the server to get back to us. So we could set our timeout for a very long time. And so we make a connection with the server, and we wait, and we wait, and we wait, and the server holds on to that connection. And as soon as something happens, then it sends a response. And so we can use that as a way for getting things back almost near to real time when they happen. And as soon as, if you want to be constantly waiting for this kind of data, generally if we're waiting on the server, it responds, we have to make another connection immediately afterwards so that we can wait for the next thing that the server is going to tell us, right? So, does anyone, what are some downsides that people think there might be to using this kind of approach? Yeah.
Is it like whenever it's hanging, it's kind of just like wasting? It might be just,
yeah.
If it takes a long time, or just not doing anything while the connection is hanging, when you could be doing like multitasking or something like that.
So there are ways that you can program it so that the server can go do other things and the client can do other things. But one thing that it is doing while that's happening is it is wasting resources. There is a connection that's open. It does have to like keep memory, and it has to keep some sort of data structure so it can keep track of, like, a server might have hundreds of these connections just like hanging open, right? So it has to kind of keep track of which these are. Every time that we have to re-up our connection to the server, we have to do a TCP handshake, which is actually like a pretty intensive operation. It takes a lot of server resources, a non-trivial amount of network resources to establish that connection. And so, if this is happening like constantly over and over again, this is creating a lot of waste in the network as well as the server's resources. And establishing a TCP connection isn't necessarily the fastest operation, so there can generate some lag if if the server has something to immediately tell us. All right. Let's see. So one potential upside to this, though, is that generally making an HTTP call in JavaScript is available on pretty much every browser that exists. And so this is something that we can do pretty much universally, even though it is kind of kludgy. Right, so we talked about how it's expensive for all of these things. So yeah, there's a lot of performance negatives potentially to long polling, but it is available everywhere. All right. Something else that can happen is if you have a bunch of these connections like coming into the server and like getting responded to and disconnected quickly, you can get some like weird ordering issues. You kind of have to be careful about like how you're queuing up your messages on the server. You do have to keep a queue on the server in case you don't have a waiting long poll request to respond to. So there's some difficulties there. All right, so that's one way of doing it. What other ways can we think about sending data back and forth between the server in real time that might be more lightweight? So I mentioned before that HTTP runs over a TCP connection. So, so can someone talk about what is like the, how does a TCP stream operate differently than a normal HTTP request? So what can you do with the TCP stream? Sorry, someone said something.
It's port-to-port communication, end-to-end.
It's end-to-end. So, but what else about it? What do you get when you have an open TCP connection? So when I have a TCP connection open, I have both an upstream and a downstream like data stream, and so I can send data up to the server, and I can send data back, and I can do this whenever I want, and I can the connection stays open. I can send however much data I want one way and however much data I want the other way. It's not I connect and disconnect. It just stays open. However, because HTTP is set up in such a way that it's specified to connect and then disconnect, that's not normally how things operate. However, right, so yeah, we can keep the TCP connection open. That's not how HTTP works though. So enter this concept of WebSockets. Have people heard of WebSockets before? No? Okay. So WebSockets are this new extension to the HTTP protocol that happened around 2010. So I feel like, in my perspective, that this is a fairly recent addition, but it's kind of getting normalized at this point. So it's an extension to HTTP. So basically what happens is you make a normal HTTP request to a server, and instead of closing it, I specify a few options which causes the server to upgrade my HTTP request to what's called a WebSocket connection, and basically the underlying TCP stream of the connection stays open. It doesn't close, and at that point I can start sending data back and forth between the server and the client in like full duplex mode. So I can send, I can send data back and forth at the same time. Don't have to wait on going back and forth. So I can send and receive data as I need it. Basically this ends up giving us the equivalent of just a TCP connection. However, it does give us some perks. One of which is that data is already framed. Can somebody explain to me what I mean by this? Okay. So whenever we look at a TCP connection, it's very much like people have like opened and read files with like C or C++, right? That's something that you do. So whenever you read a file with C, you just get like this stream of bits that come in, right? And you do get like an end of file at some point. But you have to do you potentially have to do some computing to figure out how the data is structured in that file, where pieces of data stop and end. You might have to have some markup in the language or something, or in the data, or to be able to understand the structure of it. So basically, it's similar with what framing is in a TCP data stream. So whenever I receive a message, whenever I receive an incoming TCP connection, it's just a stream of bits. There isn't necessarily anything underlying telling me when things start and stop. However, whenever we're using WebSockets, it has a little bit of functionality on top of a bare bones TCP connection, which basically tells me when I've received a certain message of a certain size, and so I don't have to like do all of that message parsing, like message size parsing myself. It just gives me a data chunk and it says this is a message. And so I can then use that to go throw that into some other kind of parser to get the data, but I don't have to keep track of like how large the messages are and that kind of thing. So that is what framing is. So you'll see how that kind of works here in a second. So if you're interested in how it differs from a normal HTTP request, this is an example of an HTTP request and response that is starting a WebSocket connection. So basically, we can just make a regular GET request. It has this particular host that we're going to. However, we specify this upgrade option, which says that we want to upgrade this connection to a WebSocket. And again, this connection upgrade here is part of saying that. We can have a couple of HTTP options, which enable us to specify some things about what WebSocket protocols we're going to use. This is just for the application to use to understand what kind of messages you're going to be sending, what kind of protocols you're implementing with the WebSocket. Don't really need to pay that much attention to that. WebSocket version. The response says, yes, we are upgrading you to a WebSocket. There's some keys that go along with accepting and establishing the connection, which you don't really need to pay attention to. And again, what protocol it's supporting, which would be the chat protocol in this example. So we've established our connection using a sort of a standard looking HTTP setup. And then after this, it'll just be back and forth data between the server and the client until the WebSocket is closed. You don't really need to pay attention to how that data looks. Just know that it's going to be, the connection is going to be staying open, and it'll be going back and forth between the client and server. All right, just to give you an idea of what programming with WebSockets would look like, it's actually very simple. So this is what the client API looks like. So this is what the API you would use in the browser would look like to interact with a with the WebSocket. So you can start up a new WebSocket. You give it a URL, a WebSocket URL. It starts with WSS, and then with the domain as well as a path. You can also specify these protocols if you have a server that's listening for that. And then you have a couple of events that this WebSocket can handle. So whenever the connection is open, we can respond by changing our application somehow, or we can send some data. So in this case, we're sending just this text string across the WebSocket to the server. The server would be listening for it and do something with it. And then this onMessage function would be whenever the server sends us a message. So if the server sends us a message, we get an event in this callback that has a .data property in it that we could then parse with our heart's delight. The typical thing you would do is to parse it into JSON, or parse it with JSON into a JavaScript object. And then you could do something with that data. Another event you can get is onClose. So if the server closes the connection or I close it, then this callback would get called, so we could respond to that change in state and stuff. Is it kind of clear like what this API is doing? It's pretty simple. It's just whenever it's open, whenever I get a message, and when things close. And I can use this this WebSocket.sends to send a message to the server. And this data just goes back and forth in real time. You can implement this if you want. I'm not going to show like what it would look like to implement pure WebSockets server in Node, because I'm going to recommend that you use another library to do that, which I'll show here a little bit. But this is, if you wanted to just implement just plain WebSockets, this is what it looks So there are some downsides to working with WebSockets. First, this is probably getting increasingly less likely. However, a lot of browsers do not actually, or at least didn't actually implement WebSockets. I would think that most do now. But you might still run into an occasional instance or someone using an old browser version, Internet Explorer, that doesn't implement WebSockets. So you can't use it in that case. And it can be difficult to establish WebSocket connections in some network environments. One way that a network can be set up is to use what's called a proxy, in which case there's a server or machine in the middle that sort of like handles incoming HTTP requests and like sends it off somewhere else and sort of can either deny certain types of requests in certain places, or it could have it so that it doesn't accept WebSocket connections for different security reasons, or that kind of thing, depending on if you're working on like a company intranet or something like that. So in that case, you wouldn't be able to use the WebSocket. So you can't potentially rely on WebSockets to work all the time. However, they are potentially offering us a lot better performance than long polling would be for sending data back and forth, right? And the upsides, they're very fast. Generally, they're lightweight. I mean, you do have to have a connection open, but once you have it open and sending the data back and forth, it's a very lightweight type of communication that you're doing. And generally, TCP requires that ordering is within a TCP connection, that ordering is maintained the same, so you're not going to run into any of those problems. Yeah.
What do you mean by ordering problems? Like,
so you can potentially run into a case with the long polling where if you have a bunch of connections going, getting made and disconnected, depending on how long data takes to get through the network, and depending on like what routes it takes, it can be that like you get like one message back before the other, or like the server could get mixed up in terms of like what order to send the messages back in. A TCP connection basically guarantees that the ordering of your messages is going to stay the same as it traverses across the network. Basically, the way that the protocol is implemented guarantees that. So the upsides. So, okay, we have these two ways of basically doing real-time communication across the network in the web environment. However, we can't necessarily use WebSockets all the time. So, what's a potential solution? If we have, what do you think, Vince?
Promises.
Not promises. Well, there might be some promises involved, but that's not necessarily going to solve all the problems. So one of these is more reliable, and that we can always use it, but doesn't perform as well as we would like in some settings. However, another one of these has better performance, but isn't always reliable. So we can write a framework, or we can use these in a way that we prioritize using WebSockets. So if we can use a WebSocket, we can communicate back and forth quickly in a lightweight way. However, if we're using a browser that doesn't have WebSockets, or we're in a network environment that can't use WebSockets, we'll fall back and use long polling, which is pretty much universally functional on most browsers and in most networks. So we combine the two together. And one package that uses this that I'm going to prioritize showing you is what a package called Socket.io, which is a library for both Node.js as well as in the browser. So whenever you're implementing these real-time communications, I'm going to suggest that you use Socket.io. It combines both of these in a semi-reliable way, and a pretty reliable way. And it adds some more functionality on top of just these plain network communication mechanisms, enabling you to do things like broadcasting messages to a lot of different clients, this kind of thing. And generally, it is implemented in a very robust way that works on pretty much all browsers and most networks. And so you can generally rely on it to send your data reliably and quickly. So let's see. I have a quick example that I'm going to try to run through for this. Let me make sure that I'm recording right. Yeah. Okay. All right, so I'm gonna go through the server implementation real quick with Node. You've seen most of this before, or a lot of this before with Express and Node, where we're requiring just Express and HTTP. These are normal Node packages that we're using to just establish having a HTTP server. This is basically just saying if I get a response or get a request on the slash path, just the home path, that I'm just dumping this index.html file out to the client, which I'll show you here in a second. Whenever, and here where we're requiring the Socket.io package, which you'll need to install with npm install, we give it our HTTP server here that we've instantiated, and basically, so WebSockets are, like as I mentioned before, an extension to HTTP, right? And so what this does is it extends our normal HTTP server, which only responds to sort of the standard GET put requests, GET put post requests that we would see. It extends that to enable clients to upgrade to a WebSocket connection or long polling. And so, but basically it abstracts all those things away so that we don't have to think about them. To where we only have to think about the very high level messages that we're sending back and forth and connections opening and closing. So that's what's happening here. So this IO object here is the Socket.io server. So we can set an event for whatever for connection. So basically what that means is anytime that a client connects to us, we call this callback. And so anytime someone opens up a browser on our page that makes a WebSocket connection to this server, we'll get this connection callback. We say console.log user connected because the user connected. And then we can send, well, this is actually not sending. This is setting up a listener for receiving a particular type of message on that, on the Socket.io connection. And so we say anytime we receive a chat message, in string form chat message, event or message from a client, basically we take that and then we say io.emit. So emit is basically sending out that message to every client that is connected. So we send out a responding chat message to everybody with the contents of that message here. If it is not obvious, from this point, this example is just a chat, a very basic text chat. And so basically this just listens for chat messages coming in, and then it sends it out to everyone that's connected. Very, very basic sort of chat. Okay. So I'll show you how this looks on the browser side. Okay, so we have a, let me just show this to you real quick so you can see kind of what it looks like. Oh, did I need to run? Oh, I haven't installed packages yet. Oh, yeah. I think this is right. Install. I think I actually have the packages installed, but I will just say Express and Socket IO.
So that's installing two, right? Two.
Yeah,
modules?
this is installing two different packages. You could have a list of 100 things long, and it'll install them all at the same time. So that's installing both Express and Socket IO. Okay, let's try running this again. Okay, so we're listening on port 3000. Localhost 3000. So we open it up, and it's just, we have a place down here where we can put in messages, and this is just a little form with a send button, and I can show you. Duplicate. So I open up multiple instances of this. I can just say hello world. So whenever I send messages, they get communicated through the server and show up on both chats. And you could have however many you want connected, and it would send the messages to all of them. So yeah, this is just sending messages back and forth. We're not doing anything more complicated than that. And just to give you an idea of what this looks like on the server. So I have some styling up here, which you don't really need to pay attention to. Okay, and so I have a script that's set up here, just embedded in the HTML file. So this onload is basic. I mentioned this before. Basically, this gets called whenever your page has fully loaded. That way, your JavaScript doesn't execute before like everything's in your page. Okay, so if you look up here, we've actually, this is how we include the Socket.io library JavaScript file, which is automatically hosted by our Node server once we start running Socket.io. So it loads that up, which gives us all of the APIs that we need for running Socket.io. This, where we say var socket gets IO, that's how we instantiate a Socket.io connection. This is actually going to, will actually connect to the Node server. This is looking up the form that I have for my chat message boxes. And then whenever I submit that form, we're doing a couple of special things. One, we do this e.prevent default. Basically what that prevents the form from doing is submitting a post request or whatever kind of request to the server and like reloading the page, which is the normal behavior of HTML forms. So we don't want that to happen, so we're saying this prevent default. And I think return false also makes sure that doesn't happen. Okay, so we get the message text, or the message input, which is just the input element that is in the file down here. So it's just a very simple HTML file. We have an unordered list of messages, and then a form with ID chat form and an input, a text input that just has the ID again, with an autocomplete and a send button. All right. So, and then once we have the message, we say socket.emit, which sends our chat message to the server. And then we give it the value of the text that is inside of that input. It goes to the server, which triggers the code that I was showing you a little while ago. We reset the chat message text to nothing because we don't want the text to be there anymore. We want a new chat message to actually get typed in, and then that's all that happens there. So that's how we send messages to the server. All right, and so whenever we receive chat messages from the server, so whenever the server gets a message from a client, it just sends it back out to all the clients. So we have this socket.on, which is looking for a particular type of message, a chat message, and it calls this callback function. So we create a new line item element with that that has a text node with the message text from that message. We put that in this node, and then we append that node to our unordered list of messages. So it just adds them from top to bottom. And we have a very basic chat client, yes.
So the chat message that you use in the emit and the on function, that's just like some arbitrary key, right? It's not predefined or anything.
It is not. Generally, you probably want those to be human readable, but these can be anything. And so, you know, if we want to have different semantics for different types of messages, we can change this text to be something else. So we could set it to like set user, or we could change it to like update game data, or we could change it to whatever you want it to be. And you would have different callbacks for those different messages, and then we could handle differently and have different logic associated with it, right? Anyone else have any questions about how this is working? Yeah.
So if you make a new instance of the page now, well, the previous messages won't be there, right? Because
Correct. They won't be there because they are only getting populated by receiving chat messages from the server. So can you think about how you could implement like having those chat messages there?
well, you just have to have a way of keeping like a history of messages, probably, to
Right.
update.
So what we would do is on the server we would have some sort of data structure that would store the history of messages. And then whenever a client connects, we would potentially automatically send a message to that client, you know, saying these are the messages, this is the message history, and then the client could like auto-populate that on its interface, and then you could go from there basically, right? So this is a very basic example. If you look on the Socket.io webpage, this is the example they sort of start with. Although they use jQuery, I ripped the jQuery out since we haven't talked about what jQuery is. But if you know what jQuery is, then you can parse that. It's pretty simple. But yeah, this is a very basic example of how you can do real-time communication with the server. And this is using WebSockets and long polling sort of seamlessly behind the scenes. So you don't really have to do that yourself. It kind of abstracts that away for you. But that is what's happening. And I wanted to go over sort of the like underlying technology so that if you did need to like work with those technologies in the future, you would know what they are, or at least have heard of them. All right. There are a couple of other pieces of functionality that Socket.io adds. Let's see, we did the example. Okay, so Socket.io, some of the other functionality are what are called namespaces and rooms, which I think I have some examples of in the following slides. Auto reconnect. So if something happens to your network connection and it disconnects, Socket.io will make the best attempt to reconnect that connection and like reestablish it, and you can keep sending messages. That kind of happens behind the scenes. You don't have to really mess with it. It also implements message buffering in that case, so that like you don't lose messages, I believe. Those are some nice things that it does for you. One thing to know, it is possible with Socket.io to just send messages to particular clients instead of broadcasting. Normally, the way that would look, I don't have that example here, but it would be like socket.to and then like an ID for a particular socket, so you have to keep track of like the different socket IDs. But you can say .to, a socket ID, and then .emit, and it'll just send that message to that person. Another sort of different way that you can send messages is in the example I showed, we just used plain emit, which sends a message to every connected client, including the one that is sending it. However, we can use the socket.broadcast.emit, which is a little bit different, in that it only sends a message to, well, it sends a message to every client except the one that is sending it. And so if you didn't want to get like a repeat of a message back on your own connection, say in our case with a chat, like whenever we send a chat, if we automatically put that chat message in that client's list of messages, then we wouldn't want to receive a message about that message again, because then we have like a duplicate. So this is a way of just preventing like sending a message back to a particular socket. So this is a small semantic difference here. We can include what are called namespaces. Basically, it looks like a URL path, although it doesn't actually. It's not actually tied in with URL paths of your pages. It's just kind of what it looks like. Whenever I'm setting up my Socket.io code on the server, I can say io.of, a particular namespace, and then I can set up events for handling connections and messages, things like that within that namespace. And so this is a useful way of like separating out different types of functionality for like different types of like protocols. So if you have like, two different games implemented on one particular like node server that like send different kinds of messages, to implement the message passing, but you don't want those to like conflict, you could use different namespaces in that case, and it would just keep them separated. Basically, this is the same as using like the protocols thing in WebSockets. It just like separates out the functionality of two different like WebSocket like protocols that you're implementing. The other thing that I could do that they have functionality for is this room. No, this is not actually client-side code. Don't pay attention to that. Fix that. So the other, so you can have sockets join what are called rooms, which are basically just identifiers for little buckets of connections. So if you thought about like our chat example, if you wanted to implement like a site that had a bunch of different chat rooms and not just one big one that everybody was connected to, you could create unique IDs for those chat rooms. And then what you do is you do the socket.join some room, and then you use this .to a room ID and then emit. And so I could have like a room A and a room B, and if I send messages to room A, then clients connected to Ruby don't see those messages. So it's a way of just, again, separating out connections so that we're not getting confused by having messages flying around between different clients that don't necessarily need to be listening to each other. Okay. I think that's the end of the functionality part of talking about Socket.io and real-time communications. I feel like it might be a little bit overwhelming, but this is actually very simple. Like, it's just sending messages, waiting for connections, and waiting for like sockets to close. The actual communication part of doing this real-time communication is not very complicated. Handling the logic can get very complicated. You have to think about what states are on different machines. So like, what are the states on all the clients? What's the state on the server? And how do you handle that like propagating appropriately? And that's just going to take some time to like internalize and conceptualize a little bit whenever you're doing this. I guess the other thing I didn't mention is that whenever I'm sending messages with the MIT, I just use text in this example, but if I just put in a JavaScript object here, it automatically gets converted to JSON and then sent across the wire, and then whenever I receive it, it automatically gets converted back into a JavaScript object. And so you can just like start messing with that data however you want to. It doesn't have to necessarily just be strings. Just an easy way of sending data back and forth in an already structured kind of way. So yeah, if you want to learn more about how Socket.io works, there's probably not a whole lot more that you need to know, but I do have a link here to the documentation, and the website is just socket.io if you want to go look it up. So any questions about how Socket.io works, how real-time communication works with these technologies? Does this seem more like overwhelming than like you would think, or more simple? Just very quiet.
It's a solid okay.
It's a solid okay.
I feel like if I get some like practice.
Yeah.
Okay. Well, you're gonna get some practice. So I already mentioned this to Vincent over the weekend, and I'll introduce the next assignment next class. But the next assignment is basically going to be taking your multiplayer games and making them multiplayer across the network using Socket.io. So, so just keep in your mind like what kind of data structures and what kind of data you're gonna have to be sending back and forth to make that happen. I know Vincent was telling me she was implementing sort of like a real-time game where people are like jumping and platforming and things. That might make it more complicated just because you're having to track things in real time. Whereas if you're just doing simple turn taking, then maybe that's a little bit more simple. But that's what's next. I'll introduce that project or that assignment formally next class, and we'll have a work day to either work on your games, and we can also talk about how you're going to set up the network connections to actually get things working. So, yeah, hopefully that's not freaking you out, but I did want to give you a little bit of a heads up. So, all right, that's it for today.
And then you
Oh, I mean, wait, that's actually.